Hey y'all, we are going to be adding and subtracting radicals, multiplying radicals. That's what we're working on today. So this little worksheet is great. It gives you the steps that you need to do on adding and subtracting. You need to simplify all radicals. Step 2, identify radicals with the same index. Remember, the index is the little number, so they have to be squares with squares, cube roots with cube roots, and the same radicand, which means the number underneath the radical. Only these can be combined. So you cannot add a square root with a cubed root, and in order to add them or subtract them, they have to have the same number in the house, okay? And then number 3 says, for common radicals, add and subtract the coefficients and keep the common radical. So what's in the house is going to stay the same. It's like your term. You add what's in front of them. So you'll see it in these examples. All right, currently number 1. If you looked at this as is, there's nothing that you could do at this point because what's inside the house is not simplified. But, well, not that it's not simplified, I'm sorry. What's inside the house is not the same. 27 and 12 are different. But both of these can be simplified because 9 is a perfect square and it's in 27, and 12 has 4, which is a perfect square, so we can simplify both of those. So that's what we need to do at first. So this goes back to yesterday's lesson. If you liked prime factorizing, then off to the side you would need to prime factorize 27 and 12. I'm just going to say 9 times 3 and 4 times 3. I like to list the perfect square first every time. 9 is a perfect square. I list it first. The square root of 9 is 3. The square root of 3 is not perfect. It stays in the house. Ta-da! Now, this 3 was already there, so I need to bring it down. Multiply 3 times 3, which gives me 9 square roots of 3. So I simplified that. These two things are equivalent. This is just simplified. Over here, same thing. The square root of 4 is perfect. It's 2. It comes out of the house. 3 is not perfect. It stays in the house. This one up here has negative 2 up front. I'm looking for a different color, y'all. So I'm taking this negative 2 right here and I'm bringing it down to multiply by 2. So negative 2 times 2 is negative 4 square roots of 3. Now, that means I'm subtracting or adding a negative. Same thing. Doesn't matter if you wanted to do 9 plus negative 4 or 9 minus 4. You are just doing the coefficients. 9 minus 4 is 5, and then in the house is 3, and that stays the same. That's your answer. The next one, you've got addition and subtraction. Remember that PEMDAS has those two things in the same step. You just work left to right. The first thing I notice is that my index number is 3 for each of those, so that is fine. Okay, I can add all of those together as long as they all simplify down to have the same thing inside the radical. So, first thing for 54, I'm looking for a perfect cube that's in 54. And if I was you, I would get out my notes from last class, which is what I'm going to do. This is Algebra 2. Let's see. Yeah. Okay, if you get out your notes from last class, you could just set this beside you, and then you could easily look over here and see what are your perfect cubes, so you would know what would divide into those evenly, unless you're just really good at those. I have to find my calculator. I'm going to pause y'all for y'all. Okay, so 54. You could do the cubed root of 54 and just check. It's not a perfect square, okay? So then I could take my perfect cubes and say, all right, 54 divided by 8. No. 54 divided by 27. That's a yes. Okay, so that means I can take that and split it up. 27 times 2. Then I'm going to take the cubed root of each of those. The cubed root of 27 is 3. That cubed root of 2 stays in the radical, and then you are going to bring down the 3. 3 times 3 is 9 cube roots of 2. Okay? Now, that's just the first one. The second one, 2 is a prime number. It is not a perfect cube, so I'm just bringing this whole thing down. Minus 2 cube roots of 2. Now, yes, those are the same, so I could do 9 minus 2, but I'm just going to wait until I deal with 16. Now, 16 is not a perfect cube root, but 8 goes into 16. 8 is a perfect cube root. I'm going to take out negative 8 times 2. Okay? Now, the cubed root of negative 8, remember it's okay for cubes to be negative, is going to be negative 2. The cubed root of 2 is not perfect, so it stays in the house. Then I take this 7 that's up there in front, and I bring it down. 7 times negative 2 is negative 14 cube roots of 2. Now, if we look at everybody, this index is the same for everybody, and the radicand is the same. So, because of that, we are able to combine these using, in this case, subtraction, but addition as well. So you would have 9 minus 2, which is 7. 7 minus 14, 9 minus 2, 7. 7 minus 14 is negative 7. And you're just dealing with the coefficient. You're still going to leave it the cubed root of 2. That is your answer. Okay? All right, to save us time, I'm going to switch over, this is geometry, to y'all's key. I think it's this one. Let this load. Well, hold on, y'all. Okay, so on 3, 4, 5, and 6, you can see them working this out. Okay, you can take a screenshot, you can look at this to figure out exactly what she's doing. These are fourth roots. I guess you can't see me pointing at that, but on number 3, you have a fourth root and a third root. I guess I could use my mouse. Yes, a fourth root and a third root, which means these simplify down like they did. You can combine the fourth roots, but you cannot combine the third root with the fourth root. So that's why your final answer has those 2 parts, and that's fine. That's as far as it'll go. Over here, same thing. This is a square root, a cubed root, a square root. So this cube root is different. Okay, it cannot be combined with the others, but you can see you simplified this one out. It was 20 square roots of 7. This one was negative 20 square roots of 7. They just cancel each other out. So this is what is left over because it cannot be combined with the others. On number 5, this is bringing in your variables, which is fine. You still simplify just the same. That x to the 4th is just going to be x squared. Y to the 2nd is going to be y. Now, again, it does have to match perfectly on the inside. Okay, so the inside matches, square roots, that's perfect. With addition, though, your rule says if you're going to add like bases, then you have to have the exact same. Okay, so this is x squared y, so that's fine. We're going to do their coefficients. 7 minus 3 gives you 4. X squared y stays the same. So you're using your Algebra 1 rules when it becomes variables. Okay, so that one's good. That's your answer. However, over here, you can see we have a cubed root, cubed root. This is going to just be multiplied, kind of like it was up here. They just put a times sign in between. No big deal. Simplify, simplify. Over here, same thing. You're simplifying. When you simplify 27a cubed, that's going to be 3a. Then you multiply that. 3 times 2 gives you 6. A to the second times a gives you a to the third. Now, this is a 3. This is a 3. Their index is 3, and what's inside the house is the same. The problem is we cannot add the coefficients together because they are not like terms. So you just leave it separate, just like we did number 3. Some of them will not simplify down. Okay? Now, let's move on to multiplying. Okay? Multiplying radicals. Now, to multiply a radical, you're going to use the product rule. Our product rule tells us that when we multiply this, and they have an index here, that index is going to stay the same. And what's inside the house is going to be multiplied together. Okay? I always say you multiply inside with inside, outside with outside. Alright? And then you just simplify. So I don't have to worry about simplifying up front. I'm going to simplify at the end. These are both square roots, so I'm going to multiply them together. 27 times 5. Okay? 27 times 5 is 135. Now, 135 is going to need to be simplified. So you have to find the perfect square that's within 135, which is 9. 9 times 15. The square root of 9 is 3. The square root of 15 is not perfect. It stays in the house. That's your answer. Now, you could have done that differently. I immediately noticed that 27 has 9 inside it. Okay, so I could have said this is going to be 9 times 3. The square root of 9 is 3. The square root of 3 stays in the house. Then I've got 3 square roots of 3 times the square root of 5. Okay, bringing this 5 down. Now I multiply inside with inside, outside with outside. This would be like 3 times 1, which is just 3. Then you have 3 times 5, because they're both inside. 3 times 5 is 15. So you can see either way you're going to get the same answer. Inside with inside, outside with outside. You just have to decide, do you want to simplify first or do you want to simplify at the end? Does not matter. Okay? For number 8, we're going to, let's just go ahead and do the multiplication and then we can simplify. So 3 times negative 2 is negative 6. Okay, and then we have 10 times 18, which gives us 180. Okay, so we're looking for the perfect square that goes into 180, which is 36 times 5. Okay, then you're going to take the square root of 36, which is 6. The square root of 5 is not perfect, so it stays in the radical. Then we bring down that negative 6, and you multiply what's on the outside times negative 6. Negative 6 times 6 gives you negative 36 square roots of 5. Now, I'm able to do that quickly because I have a key right beside me. Okay? So, I'm going to just tell you that for me, it's going to be easier for me to simplify first. Okay? I know that 9 is a factor of 18, and so I could have simplified that first, and then I wouldn't have had so much to simplify at the end. It doesn't matter, though. You do what's easier for you in terms of simplifying. Let me go back to show you guys the key. I'm trying to speed this up. I'm already 15 minutes into this thing. All right, so this is cubed root. This is cubed root. So we have the cubed root of 9 and the cubed root of negative 24. You multiply that together. That gives you negative 216. 2 times 5 is on the outside. That gives you 10. This is a perfect cube. So you take the cubed root of that. It gives you negative 6. Multiply those two things together. Negative 60. There is no cubed root because it was perfect. Okay? Over here, this is the fourth root. You multiply 64 times 8. That gives you 512. Split 512 into 256 and 2. Then 256 is a perfect square. It gives you, a perfect fourth. It is the answer is 4 as well. So 4 times 3 gives you 12. And then that stays in the house. Okay? Then they start to bring in the letters. Works the same way. This is a cubed root. This is the square root. So 6 is not perfect. This is perfect, but since we're multiplying, we're just going to continue to multiply first. This doesn't have anything on the outside, so it'd be like 1 times 5, which is 5. 6 times 8 is 48. This is the fourth power. This is the fifth power. You add those together to get 9. Then you begin the simplifying process. 16 is perfect, and 8 of those would be perfect. So 16 times 3, 3 is going to be not perfect, and then your leftover x stays there. You simplify your perfect square, multiply times 5. That's going to give you 20x to the fourth, 3x there. So you're just multiplying first, simplifying to get those answers. You can screenshot that. You can look at that to see how they are doing that when it deals with the numbers. She does a good job with that. Okay, now the next part is the binomials. Okay? So if we look at the binomials, remember that means that you have two parts. Now, some of you I know love to do the area model when it gets time to do FOIL, so I will show you that as well. This is just the distributive property. So we're taking that square root of 10 and you are distributing it inside the parentheses. So it's just going to go to both. You're just doing the distributive property. So we have the square root of 10 times 5 square roots of 5. So that's going to be 5 square roots of 50 minus 2 square roots of 20. Okay? Then you have to look at each one of those and decide, is there a perfect square within that? Well, this definitely has 25 times 2. Okay? The square root of 25 is 5. The square root of 2 is not perfect. It stays in the radical. This 5 comes down and multiplies. 5 times 5 is 25 square roots of 2. Okay, so that simplifies the first part. This one has 4 as a factor. 4 times 5. Okay, the square root of 4 is 2. The square root of 5 stays in the radical. Bring down that negative 2. Negative 2 times 2 is negative 4 square roots of 5. Now, this is subtraction, so it goes back to the subtraction rules. In order for us to subtract, they have to have the same number in the house. This has 2. This has 5. That is not the same number, so this is as far as we can go. That would be our answer. Okay? Now, number 16. If we look at number 16, this is where we're looking at our binomial times a binomial, which means I am going to have to do FOIL, first, outer, inner, last. So I'll be multiplying 8 times 3, which gives me 24. Then I'm multiplying 8 times negative 10. This is on the outside, this is on the inside, so I don't get to multiply those together. So it's going to be 8 times negative 1, which would be negative 8 square roots of 10. Then I do negative 10 times 3. Again, same thing. This would be like negative 1 times 3, which is negative 3 square roots of 10. And then this is going to be inside the radical with inside the radical. So we have a negative 1 times negative 1, which is positive 1, which I'm not going to write the 1, but it would be positive. Then we have the square root of 10 times 10, which is 100. Well, that's a perfect square. Okay, 10 times 10 gives you 100. The the square root of 100 is 10, not in the radical. So 10 is now like terms with 24. That gives us 34. Okay? Now, because we're back to our addition and subtraction rules, no longer am I multiplying, now I'm combining like the like terms, the ones that have the like parts. So if I look at this one, these both have the square root of 10, the square root of 10. So what I'm going to do is I'm going to add their coefficients. Negative 8 and negative 3, that would be like negative 8 plus negative 3 is going to give me negative 11 square roots of 10. Now, if we look at this, we're not able to simplify that anymore because 34 doesn't have the square root of 10, so that means this is my final answer. Okay? If you like to do the house, let me show you all that. If you like to do, not the house, I'm sorry, the box. Like I know Hadley really likes that, and some of the others like this as well. You do positive 8, negative square roots of 10. Then you do positive 3, negative square roots of 10. Okay, so then you just get 24, negative 3 square roots of 10, negative 8 square roots of 10, and this would be positive square roots of 100. Okay, that is going to give you 10. Okay, so then these are going to be like terms, and that's going to give you the negative 11 square roots of 10. But now these are also like terms, which is where we get the 34. Okay, it's kind of like imaginary numbers. If you're remembering the imaginary numbers, it's very similar to that. Okay, I don't care which way you do. If you like the area model, you can do it this way, or you can do just typical FOIL, whatever's best for you. Okay, number 17 is just like that. So let's switch back over to the key. I'm already to 22 minutes. If you guys are still watching this, you are incredible. So 17, if you look at this one, you can see that she's doing FOIL. She's got all of her pieces together. Then she begins to simplify. The square root of 36 is perfect, so that's 6 times 6, which gives her 36. This is a positive, this is a negative, so that cancels out. And then 4 is a perfect square, that gives her 2 times negative 6, which gives her negative 12, which gives her 24. Okay, over here, remember, anytime you see a square on the outside of a binomial, you have to write it twice. Don't forget that. This one is just distributive property, and then this one is again doing FOIL. Okay, the last one on this page talks about the area and perimeter. Remember that area is multiplying the length times the width, so you would need to do FOIL for that one. And then perimeter is adding all of your sides. So what they've done is they've taken this side and they're saying I need 2 of those. So 2 times that, you just distribute that 2. And then for this one, 2 times this, distribute that 2. And then you combine the ones that are alike, which are really just the 6s. And then everything that's different stays by itself. Okay, I hope that this helped you be able to add, subtract, and multiply as you're doing your homework assignment. If you have questions, you guys feel free to reach out to me. All right.